Imagine a day when humanity finally steps beyond Earth and begins to build a new home on the red planet, Mars. But this dream, beautiful and bold, hides a reality filled with danger, uncertainty, and sacrifice. In 2025, humanity stands at the edge of a new chapter. SpaceX, NASA, and international partners are preparing missions that could finally make the first human presence on Mars possible. Yet, behind the headlines of progress lie unseen challenges: radiation, isolation, survival, and ethics. Welcome to Mars 2025, Building a New Home, the unseen challenges of Martian colonization. Let's explore what it will truly take to build humanity's second home, millions of kilometers away from Earth. For decades, Mars has captured our imagination. It's the planet most like Earth in our solar system, with polar ice caps, seasons, and a day just 40 minutes longer than ours. Scientists see it as a natural next step. If life ever existed beyond Earth, Mars is the best place to look. But distance makes it a giant challenge. Traveling to Mars means a journey of 6 to 9 months through deep space. During this long voyage, astronauts will face months of weightlessness, their muscles weakening and bones losing strength. Cosmic radiation continuously bombards the spacecraft, slowly damaging cells and increasing cancer risks. Outside the window, there's only silence and darkness, millions of miles from home. And if something breaks, there is no rescue mission coming. Communication with Earth can take up to 20 minutes each way, so every decision must be made alone, in isolation. As the crew drifts through the endless void between two worlds, communication delays can stretch up to 22 minutes each way. The environment is harsh. The thin atmosphere is made mostly of carbon dioxide. Temperatures can drop below minus 100 degrees Celsius, and radiation bombards the surface every second. Still, the human spirit pushes forward, and 2025 may become the year we take our biggest leap yet toward a new world. But let's imagine, after facing every challenge of the long journey, humanity finally sets foot on Mars. A new chapter begins. Humanity stands on another world for the first time. The red dust rises beneath their boots, and the silent Martian plains stretch endlessly to the horizon. But this is only the beginning. Now they must learn to live here, to breathe, to grow food, to build shelters. On a planet where the atmosphere is toxic, temperatures drop far below freezing, and a single mistake can mean the difference between life and death. Every sunrise on Mars is both a miracle and a reminder that survival on this planet is not a conquest, but a constant struggle for existence.
Sometimes you have to do something just to show that you can do it. When the Wright brothers flew for the first time, they flew an experimental aircraft. And in the same way, the Mars helicopter is designed to show that we can fly powered helicopter flight in the Martian atmosphere.
From day one, this was the unwavering dream of our team, to get our helicopter launched to Mars so that we can get that opportunity to do that very first rotorcraft flight test in the actual environment of Mars. It's extremely difficult to fly at Mars because the atmosphere is so thin. Compared to Earth, at Mars it's less than 1%.
Deep within the western hemisphere of Mars lies Amazonas Planitia, one of the flattest regions in the entire solar system. From orbit, it stretches for over 1,000 kilometers, a vast plain shaped by ancient lava flows. Billions of years ago, this place was alive with volcanic energy. Molten rivers once flowed here, spreading across the Martian crust and smoothing the land into an endless plain. Scientists believe Amazonas Planitia hides a frozen secret beneath its surface, ancient ice deposits buried under layers of dust and rock. This hidden water could one day sustain human explorers, providing life support and even fuel for rockets. Because of its flat terrain and calm weather, NASA has identified this area as one of the most promising future landing zones for human missions. It's a place where technology and hope might meet. where the first Martian base could rise, surrounded by the silent red desert. In many ways, Amazonas Planitia represents Mars itself, ancient, mysterious, and full of potential for a new beginning. Before the first human sets foot on Mars, an army of robots will arrive. Machines, not astronauts, will take the very first steps toward building a new world. Their mission: to explore, to test, and to prepare the ground for those who will follow. These early robotic missions will map every grain of dust, every rock formation, and every hint of buried ice beneath the Martian soil. Because before we build, we must find what we need to survive. The first priority: water. Not for drinking alone, but for everything. To grow food, to make oxygen, and even to create rocket fuel for the journey home. Satellites have already revealed clues: bright patches near the poles, icy deposits just below the surface. Robots will dig, drill, and melt the soil, confirming where humanity's lifeline truly lies. Once water is found, the real construction begins. NASA and SpaceX are designing habitats, sealed domes made of radiation-resistant materials, buried partly under Martian soil, to shield from cosmic rays. Massive autonomous rovers and 3D printers will start transforming Martian regolith, that dusty, iron-rich soil, into something incredible. Habitats. Walls will rise layer by layer, printed directly from the ground beneath their wheels. Inflatable living modules, shipped from Earth, will expand inside these shells, protected from radiation and freezing cold by thick layers of local dust. Nearby, power systems will come online. Solar farms will unfold like metallic flowers, spreading across the Crimson Plain. And in the shadow of those panels, compact nuclear reactors will hum softly, ensuring life continues even through months of darkness. Next comes the heartbeat of the colony: life support. Machines will split water into oxygen and hydrogen. Filters will recycle every breath, every drop, every molecule. Because on Mars, nothing can be wasted. This is where in situ resource utilization, or ISRU, becomes the key to survival. Instead of relying on constant resupply from Earth, settlers will use what Mars itself provides. Ice becomes water, water becomes air, carbon dioxide from the thin atmosphere becomes fuel, and the very soil beneath their boots becomes shelter. And, of course, communication towers, greenhouses, and research labs will form the first human settlement. Human missions to Mars may use lasers to stay in touch with Earth. A laser communication system at Mars could send large amounts of real-time information and data, including high-definition images and video feeds. The SCAN, Space Communications and Navigation, program operates and manages the communications and navigation systems that are critical to every NASA mission.
We are SCAN. We are advancing today's space communication and navigation services and technologies to meet tomorrow's challenges. SCAN is committed to ensuring vital space communications through a network of complex ground stations and tracking data relay satellites. Together, these systems enable continuous communications and global coverage for space programs. Every space mission delivers terabytes of vital information for the process of scientific discovery. Our extensible and expandable communication and navigation infrastructure provides a resilient space framework that can meet the growing requirements of our users. We develop, operate, manage, and engineer pioneering solutions. Transformational technologies in satellite communications are underway. Cognitive systems will enable autonomous satellite networks, and optical communications will increase our ability to send and receive data to the vastness of space. We are developing these and other technologies to advance explorations of Earth, the lunar region, and beyond. Spectrum, the medium that enables communications and navigation. Through coordination, we ensure efficient use of this limited resource. We work with P&T partners to provide space missions accurate position and timing information. The most exciting part of this journey lies ahead, collaborating with commercial industry on major advancements in space communications. Our next generation of visionaries are creating a bright future, enabling Artemis lunar communications and a pathway to Mars. NASA Space Communications and Navigation. Scan. Exploration enabled.
SpaceX's Starship, still under testing, is expected to carry over 100 tons of cargo per flight, including food, habitats, and rovers. Elon Musk believes that within 20 years, 1 million people could be living on Mars. But dreams are fragile, and Mars is not an easy neighbor. These first steps may not look dramatic. No flags, no cheering crowds. But they are the most important steps humanity will ever take. Building a home on Mars is far more than just landing there. It's about surviving and then learning how to truly live. The first problem, oxygen. Mars' atmosphere is 95% carbon dioxide, and every breath of air must be created artificially. NASA's MOXIE experiment has already proven that oxygen can be extracted from Martian air, but scaling that for an entire colony, that's an engineering nightmare. MOXIE is a payload instrument inside NASA's Mars 2020 Perseverance rover and is close to the size of a car battery. As NASA prepares for human exploration of Mars, MOXIE will demonstrate a way future explorers might make oxygen from the Martian atmosphere. It could one day be used to create rocket propellant to blast astronauts off the surface of the planet, in addition to serving as oxygen for breathing. Once shelter is secured, the next challenge begins: food. Nothing grows in Mars' dry, toxic soil, so humans will have to bring life to it artificially. That's where enclosed biomes come in, sealed environments where plants can grow in controlled light, humidity, and temperature. Hydroponics and aeroponics will replace traditional farming. Instead of soil, plants will grow with their roots suspended in nutrient-rich water or fine mist, under artificial LED sunlight. Each leaf, each seedling will be carefully monitored, because every calorie matters. Future colonies may also use bioreactors, systems that can grow edible algae, yeast, or even lab-grown meat. IT might not sound appetizing, but on Mars, efficiency is survival. Water from melted ice and oxygen from electrolysis will sustain both humans and crops in a closed, recycling ecosystem. The dream is self-sufficiency, a colony that no longer depends on constant resupply from Earth. When that happens, Mars won't just be a base, it will become a home. But perhaps the most terrifying of all are the Martian dust storms. Massive walls of red dust that can cover the entire planet for months. These storms can darken the sky, reduce visibility to almost zero, and damage machinery, communication systems, and even life support equipment. They are unpredictable, stretching thousands of kilometers. And when they rise, everything, technology and humans alike, must fight to endure. Martian habitats must be designed to protect against intense radiation, freezing temperatures, and frequent dust storms that can last for weeks or even months. And then comes the psychological toll. Living in small, isolated habitats millions of miles from Earth, cut off from family, sunlight, and the blue sky they once knew. Every message from Earth arrives after long minutes of silence, and every night they stare at the tiny blue in the sky. Their home, now so far away. Perhaps the greatest challenge isn't physical, it's psychological. Imagine living years away from Earth, seeing the same faces every day, in a small confined space with no escape. Outside your habitat, death waits in the thin, freezing air. Inside, isolation and monotony can slowly erode mental health. NASA's behavioral scientists already study this through long-duration isolation missions on Earth, like HICs in Hawaii or Concordia Station in Antarctica. Their results show that even trained astronauts struggle with loneliness, stress, and group tension over time. To combat this, future Martian colonies will include virtual reality rooms, artificial day-night cycles, and communication links to Earth with delay-resistant AI companions, digital partners to help maintain morale. Social structure will also be critical. Rotating leadership, shared tasks, and strong community bonds could mean the difference between harmony and breakdown. On Mars, cooperation won't just be a virtue, it will be a necessity. Everyday life will be a constant routine of maintenance, monitoring, and teamwork. Checking oxygen levels, repairing systems, growing food, and conserving water. There will be no weekends, no sunlight picnics, no rain. Yet, despite the hardship, each sunrise over the red horizon will remind humanity of why we came, to begin again. Once survival is secured on Mars, once shelters, food, and oxygen become reliable, a new challenge begins, building a society. Who will make the laws of this new world? On Earth, we are divided by countries, governments, and borders. But on Mars, there are no nations, only pioneers. So, who decides what is right or wrong? Who owns the land? Will Mars be ruled by Earth-based agencies like NASA and SpaceX? Or will its settlers demand their own independence, forming the first Martian government, creating fair laws and systems of justice in such an isolated world will be crucial. Even a small conflict could threaten the survival of an entire colony. That's why early Martian societies might rely on AI-assisted governance, transparent systems that balance human freedom with the safety of all. Economically, Mars could become the heart of a new interplanetary economy. In the beginning, resources will flow from Earth, equipment, food, and technology. But soon, Mars must learn to sustain itself. Through resource extraction from the Martian soil, scientific research funded by global institutions, and even space tourism, where only the brave and wealthy might travel millions of kilometers, just to experience life on another planet. As generations pass, something extraordinary will happen. A unique Martian culture will begin to emerge. Children born under the pale pink sky will see Mars as their true home, not Earth. Their art, language, and way of life will evolve differently, shaped by the planet's red deserts, low gravity, and distant sun. Mars will not just be a colony, it will become a new civilization, with its own identity, dreams, and destiny. A living proof that humanity can grow roots beyond Earth. The year is 2035. After years of trials, failures, and breakthroughs, humanity has finally begun to build a new home on Mars. The first colonies rise slowly across the red horizon, shining domes made of transparent polymers and reinforced alloys, built to protect humans from radiation, freezing nights, and the deadly Martian dust. Inside these domes, life begins to take shape. Tiny green plants grow under artificial sunlight, powered by smart solar grids. Water extracted from underground ice flows through purified pipelines. Every drop, every breath, every grain of soil, carefully recycled, perfectly balanced. Because nothing can be wasted here, children born on Mars take their first steps in lower gravity, learning to walk and run under the soft, red glow of a distant sun. They will never know blue skies or oceans, but they will call this alien world home. Outside the colonies, robotic fleets work tirelessly, autonomous rovers digging tunnels, 3D printers constructing shelters layer by layer, while drones scan the horizon for new resources. Human engineers, guided by AI, control entire construction systems remotely, turning barren land into sustainable living zones. Yet, challenges remain. Even in 2035, the threat of radiation, dust storms, and psychological isolation never disappears. Colonists live inside pressurized domes, unable to step outside without suits. Communication with Earth is still slow. A single message takes nearly 20 minutes to arrive. But these people are no longer just explorers. They're pioneers of a new world. NASA's long-term plan now includes self-sustaining habitats, miniature ecosystems capable of producing food, air, and fuel for decades. Hydroponic farms grow crops in nutrient-rich water. Bacteria and algae recycle carbon dioxide into oxygen. And advanced 3D bioprinters can even create tools, parts, and medical supplies on demand. Meanwhile, private companies, SpaceX, Blue Origin, and others, are racing to build interplanetary transport systems, reducing travel time and sending cargo ships filled with supplies, robots, and new settlers every few months. By 2035, Mars is no longer a distant dream. It's humanity's second home in progress. Cities like Ares Prime and New Horizon emerge across the dusty plains, connected by pressurized tunnels and powered by fusion energy. Artificial intelligence manages entire colonies, monitoring oxygen levels, energy flow, and health data of every resident. After establishing the first habitats and ensuring life can endure the harsh Martian environment, humanity's gaze turns toward the future. Scientists and visionaries are now exploring the idea of terraforming, the process of transforming Mars into a world more like Earth. It's an enormous challenge, but one that sparks hope. Could we one day create a breathable atmosphere, melt the polar ice caps to release water, and warm the planet using sunlight or advanced technologies? Though these plans may take centuries or even millennia, they mark the beginning of something profound. The idea that Mars could eventually become a second home for humanity, a living planet shaped by human hands. But Mars is not the final destination. It's the launch pad for the next great leap. Once humans master life on Mars, we'll have a knowledge and technology to explore even farther. The moons of Jupiter and Saturn, the icy worlds of the outer solar system, and perhaps, one day, worlds around other stars. Becoming a multi-planetary species will change everything we know about ourselves. It will unite humankind with a shared purpose, not as nations divided by borders, but as explorers of the same cosmic ocean. This is the legacy of Mars, not just to survive beyond Earth, but to expand the story of life itself, far beyond the blue planet where it began. At night, when the two moons, Phobos and Deimos, rise together in the crimson sky, the colonists gather in observation domes, looking back toward the faint blue dot called Earth, a reminder of where they came from and how far they've journeyed to build a new beginning among the stars. Mars is no longer the end of our journey. It's the first step toward humanity's eternal home among the stars.